The last section on logarithms is 7.4. And it basically takes everything that we've learned, the different properties, the rules, combines it all together to solve equations. So goal today is, I think, pretty much every problem you want to get a number for the answer. Okay, that's what we're doing. Solving, try to figure out what x is, or whatever the variable is. Okay. So here's our first equation. So it says 2 log base 5x equals log base 5, 9. Now, there's not really a lot we can do here, but my hint would be to focus on the left. And there is a property we learned yesterday that you can use on the left-hand side. Anybody see something we could do on the left? Yep.
And put the 2 on the left side as an exponent.
Yep. Put the 2 back as an exponent. So we're just trying to combine it back together a little bit. Now, we have log base 5x squared equals log base 5, 9. Okay, remember what equals means. It means they have to match. What's on the left has to match what's on the right. Is there anything on the left and on the right that already matches? Yeah? The bases, right? This part on the left already matches this part on the right. So you don't have to focus on that part. What you have to focus on is the part that has a variable. You have to pick a number for x that would make what's in that box match what's in that box. And then you're done. So what, anybody think they know what x would be? Yeah, x would be 3. And that's it. So if you plug in 3 for x, 3 squared is 9. And on the left, that gives you log base 5, 9. On the right, log base 5, 9. So you've made what's on the left and on the right match. Now, they're not all that short. There are some that are longer, but there are some others that are that quick. Questions on that? All right, let's take a look at this one. Log base 4, x plus 3, plus log base 4, 2 minus x equals 1. Okay, looking at that one, and kind of give you a hint. How many logarithms do you have on the left-hand side? Yep, 2. Do the bases match? What can you do with 2 logs where the bases match? You can take those 2 logs and do what? We can't cancel them, but we can do something else with them. We learned yesterday. This will be not one of the first 4 properties we learned, but kind of the middle part of the lesson. We went over those 3 properties, the group of 3. Have a guess what we could check? Yeah? Combine them into 1 log. So anytime you see 2 logs that are separate, try putting them together as 1 log. Don't worry about what the step is after that. Just try putting them together and then go from there. All right. So these 2 logs are added. When we combine them, we're going to have 1 log. When you have addition, how does it recombine? What operation do you use? Multiplication. So we need to take the 2 arguments, that, and multiply them together. Okay, so I'm going to just put a bracket and put x plus 3 times 2 minus x. Okay, so the addition turned into multiplication. Now we need to do that out. There's a word sometimes you learn in Algebra 1 to do this out. Does anybody know the word I'm thinking of? Yep, distributive property or FOIL. Sometimes people learn that because you multiply the first, the outer, inner, last. All right, so let's do that up. All right, so get a little bit of arithmetic, well, not arithmetic, more of a FOIL distributive. Once we do that, then we'll take a look at what happens. So Alyssa, when I multiply out the first, what do I get with x times 2? Yeah, let's put 2x. And max, x times negative x. Yeah, max. Yeah. That would be like negative x plus negative x. No, not negative x. You want to help them out? Yeah.
Negative x squared.
Negative x squared. Okay, 3 times 2 gives me 6. 3 times negative x, negative 3x. Still equal to 1. All right, let's take a look at what's inside those brackets. Brianna, is there anything I can do inside the brackets?
2x minus 3x.
Yep, I can combine like terms, and I'm going to put it in descending order at the same time, which means squared term first, then the x term, then the constant. Right. Now, if I was foiling this out, I probably would have done this step at the same time. But to show you guys, I'm going to write out every step so we're not skipping anything. You can see everything. All right. So put the negative x squared first. That's purely just because I like things in highest exponent to lowest. Because we're going to be getting ready to do something which I showed you guys right before we started the notes. So negative x squared, 2x minus 3x gives me negative x plus 6 equals 1. Okay, so now we've combined everything into one log. And we started with 2. Now we've got 1. So, looking at this statement right here, we have 2 different formats that our equations can be in this week. Anthony, what kind of equation is this? There's 2 to pick from. This is what we learned on Monday. Sebastian?
Is it a log?
Yep, it's a log equation. What's the other one? Exponential. So the only thing we can do at this point, because there's no numbers in front to move, there's nothing to combine together, only thing we can try is changing it from log to exponential. All right. So let's see what happens when we do that. Riley, what's my base?
4.
4. Madison, logarithm always equals what kind of number? Exponent. So 4 to the first power equals, and Megan, what do you call this whole thing in the bracket?
Right.
It's the argument, and the argument always ends up alone on the other side. So now at this point, we've gotten the log out of it. It's gone. From here, this is an algebra 1 equation. It's a quadratic. The highest exponent is a 2, and we have to solve it. Does anybody remember when we're solving a quadratic, what you normally try to get it equal to? Try to get this on one side by itself. Yep. Well, because it's a quadratic, we're not going to be able to get x by itself without using either factoring or quadratic formula, but we try to get it equal to a certain number. Remember when you solve a quadratic, what you have to get it equal to? Well, let's try getting it equal to 0. 0 x. Okay. So, there's a couple ways we could get it equal to 0. You basically have to put everything on one side. Now, the thing I don't like right now is this. Because we're getting ready to do something, and that negative is going to be kind of annoying. So what I would do is put everything on the left side. I don't care about the signs of anything else. I just really don't want the x1, x squared, to be a negative. So So how would you move negative x squared to the left? Steve? Yeah, just add it to the other side. All right, so we get rid of that and that. Let's keep going so I don't have to write this 3 separate times. I want to get this negative x over on the other side. So how would I, Jason, how would I move that one?
Add both sides.
Just add that one. That's gone. That's gone. So far, there's not really any like terms you can combine in this left-hand side. But there will be in a second. Minus 6, minus 6. Okay, so now, all you have on the right-hand side is 0. And on the left, again, we'll put it in descending order. X squared, and there's nothing to combine it with. Just look at what's circled. So x squared plus x. And what about my constant? What's my number going to be right there? Yeah. 4 to the first power is 4. Take away 6 is negative 2. Okay. So now we've got your quadratic equal to 0. And I mentioned this earlier. You have 2 options for solving a quadratic. What's one of them? We can try to do something. We practiced it right before. Yeah. We got it equal to 0. So we got that. So now it's the step after we get it equal to 0. You can either factor it, if it factors, or if it doesn't, you're going to have to use, what could you use if it doesn't factor? You're going to have to use the quadratic formula, which we all remember. So let's try to factor it and see if it does factor. Right? What's the first thing I write down anytime I have to factor something? It doesn't even really matter what the numbers are yet. About Andrew? Tell me the first thing I have to write down to factor. It doesn't matter what the number, it's more of just like a visual thing you do. Every time you factor a quadratic. You remember? Yep. Parentheses. Right? Always put 2 sets of parentheses. Alright, so we got that. What's the next thing I would put inside those parentheses? Yeah. Right, we have to figure out 2 things that would multiply to give me x squared. Well, the only 2 things would be x and x. All right, now I need my signs. We have a plus and a minus in the quadratic. So what does that mean my signs are going to be when I try to factor? Yep. It will be a plus and a minus. Basically, the idea is you're going to have to multiply 2 numbers together to get a negative. The only way you can multiply 2 things together and get a negative is if one's positive and one's negative. Now I need 2 numbers that multiply to give me 2. And add or subtract, well, subtract to give me 1. So what 2 numbers multiply to give me 2 and subtract to give me 1? Yep. 1 and 2. And it makes a difference which one I put where. Do you want to do 1 and 2 or 2 and 1? Yep, 1 and 2. Let's just check it. X times x is x squared. Okay. X times negative 2. All right. 1 times x, negative 2x plus 1x gave me negative 1x. Is that what I wanted in the middle? No. So because I got the opposite of what I wanted, all I have to do is something simple here. How do I fix that to get what I want? You flip the signs. Plus, minus. Let's check it. X squared, that's the same. X times 2 is positive 2x. Negative 1 times x is negative x. 2x, take away 1x is 1x. Perfect. So now we factored it correctly. All right. Now we're at the last step. You're multiplying that times that, and you're getting 0 as the answer. What's the only way you can multiply 2 things together and have the answer come out to 0.
It's multiplied by 0.
Right, you have to multiply by 0. Either something times 0, 0 times something, or 0 times 0. So either this has to be 0, or the second one has to come out to 0. So Courtney, what would make this first factor 0?
Positive 1.
Yep. And how about the second factor?
A negative 2.
A negative 2. If you plug in positive 1, you'd have 1 minus 1 is 0. And then 0 times 1 plus 2, 0 times 3 is 0. And those are our two possible answers. Question on how we got to that. So, very last thing, we just have to check and make sure that they both work. Because you're not allowed to take the log of a negative number. If we plug one of those in, and we end up taking the log of a negative number, we need to go back and cross the answer out. Right? It's not because we did anything wrong, it's just that's how these problems go. So when you're solving this, there's three things that could happen. Both of those answers work. That's one. One answer works, one answer doesn't. That's the second thing. Third thing is both answers don't work. So after doing all that, then there is no solution to the problem. Let's check one. Right, if we plug in 1, what's 1 plus 3? 4? Is that a positive? Yep, then that's okay. So that one will work out. Let's try it here. What's 2 minus 1? 1. That's positive, okay? So no problem there. And so that one works. Let's check negative 2. What's negative 2 plus 3? Okay. 1. Okay, so that's okay. Let's plug in negative. Wait, we plug in negative 2, right? Yeah. What's 2 minus negative 2? 4. Is that positive? Yep. Then we're good. Both of those answers work. Okay, they're both fine. I'll come back and do one of these at the end where one answer works, one answer doesn't. Okay. But here, they both work. All right, so as far as kind of like the most difficult thing today, that's probably it. Okay. So once you get past this step with the arrow, it's all stuff that's from Algebra 1. The only stuff that I taught you this week is how to combine logs and how to change to exponential form. But after that, it's all stuff you have to already kind of know. But we'll try one more of those. All right, let's do this one first. It's a much shorter equation than the last one. It looks shorter. It is shorter. It's easier. Right? It's not as much going on here. So, any suggestions what I could do here? Yeah. Yeah. You don't have multiple logs to combine. You only have one, so that's out. You don't have numbers in front to put back as exponents. You can't do that. The only thing you can try is put it in exponential form. So, Megan, could you put that in exponential form?
3 to the power of 9.
That's it. 3 to the power of 9 equals x. The only thing they could ask you to do there is just to do it out. Right? But if this number starts to get really big, if it's in the millions or billions, they're not going to have you do it out. 3 to the 9th it's kind of big. It's not like in the billions big, but it's 19,683. Big enough I wouldn't have you do it by hand. Right? But that's probably big enough that they would leave the answer as 3 to the 9th. Any questions on that? Let's try this one. So this is very similar to one of the first problems I put up in the week. I showed you problems like this, and I said, this is why we use logarithms. And I gave you guys ones like this. 2 2 to the x equals 4. 2 to the x equals 8. Most people were able to give me those answers. And then I changed it to a number like this, and all of a sudden it was harder because 5 is not a power of 2. So now we have the answer here is going to be a decimal. 2 to the second power is 4. So that's too small. 2 to the third power is 8. That's too big. So the answer is somewhere between 2 and 3. Right. Any suggestions what I could try here?
Square root of 5.
Can I do what?
Square root of 5.
Take the square root of 5? You could, but if you do that, then you would have something like this. That's what would happen if you took the square root of both sides. We don't want to do that. But at least you try. Give it a shot. If this exponent was a 2, and you had a variable like this, then yes, you would take a square root of both sides. But in this case, it's flipped. 2 is in the base. So something else we could try. Yep.
Change the log.
Change to log. See what happens. Okay, so there's your log. How about Alyssa? What's my base? What's my base? 2. Yep. Good. And you share a logarithm always equals what kind of number? So the exponent here is x. And Elizabeth, what do you call the thing that goes right here?
5.
Anyone remember what's it called? Yep. It's the argument. It's the thing that's by itself. And that's our answer. Now, we just have to type that in and see what it comes out to. Do I have a button for base 2 on the calculator? No. Then I'm going to have to rewrite that in a way so I can type it in. Anyone remember from yesterday how we can rewrite that? Yeah. Okay. Yeah, log 5 over log 2. And that's your change of base formula. So it's log of the argument divided by log of the base. Now, you just said log. You didn't tell me a base on the log. So what base are you assuming? I don't have a button for base 1 log on the calculator. Yep. Base 10. That's why. Now, say for some weird reason you didn't have a log button on your calculator. Is there another way you could write that? Without the log? Yep.
ln.
You could do ln. It will come out the same. So log 5 divided by log 2. But don't mix them. If you're going to use log, use the word log. If you're going to use ln's, use ln's. Don't use one of each. And we get about 2.32. And that's what we thought the answer should be. X to the second power was too small. X to the third power was too big. So 2.32. You'll have plenty of time to do the test, more than usual. So if you wanted to check it, you could just take 2.32, plug it in, make sure 2 to the 2.32 comes out to 5. Alright, so it's kind of the same as example 4. So Pat, how would I do this one based on just doing example 4? Exactly, just change it to log form. Andrew, what's my base? 3. Brianna, the logarithm will equal x, because that's my exponent. And Sebastian, by argument, would be
24.
24. And if they wanted that as a decimal, you do the same thing we did on the last problem. Questions on that? Alright, this one's basically like the last two, but there's one extra step. When you have an exponential equation, you want it to look like this. That one doesn't. It's got something extra in front of the box where the 3 would be in. So that 8, I just don't want there. I want that on the other side. So then everything is, it's all in one box. So how would I move the 8 over to the other side?
5.
Yeah. Just divide both sides by 8. And now you have 3 to the x equals 5/8. And now it's just like the last two. Change to log form. Base is 3. Logarithm always equals the exponent. Argument is whatever was by itself. Now you don't have to write 5/8 as a decimal. Don't bother with that. Just leave it as 5/8. And if they want a decimal answer, you got to type it in just the way we did example 4. Okay. Questions on that one? All right. Example 7. I told you we're gonna skip over that one because I want to do one more like what's on the test, which was example 2. Right. That's where we had to factor and set it equal to 0. So we'll try one more of those. Let's look at this one. Now, if you look at that quickly, you might think it's kind of like example 2. But what's different here that kind of messes you up a little bit, yeah?
Bases are different.
Bases are different. You can't combine those. It's like trying to add 3x and 2x, or 3x and 2y. Can't. They're not the same. So with a problem like this, the only thing that you could try first is changing each one of those using the change of base formula, right? But all I want you to really see in this one is that the bases are different, okay? That's all I wanted you to notice. So you can't just take any logs that are added and always put them together. Only if the bases are the same. So here, bases are different. Doesn't mean you can't solve it. Yes, you can. You can still solve it. Can't spell different. So bases are different, so they cannot be combined. Here bases are different, so logs cannot be put together. I just want you to notice that. But yes, there is still a way to solve it relatively easily by hand. Okay, but that's all I want you to see there. All right, this one. Okay, it's not a very long equation. Just x plus e to the x equals 2. The problem is you have a variable in 2 different spots. One of them is an exponent. One of them is out in front. That's what makes it kind of hard. If you didn't have this, all you'd have to do to solve this problem is minus e from each side. Right? E is just the number 2.718. So you do 2 minus 2.718. But that's not what our problem is. E has an exponent on it, so you can't do that. Well, if this x wasn't here, and that's all you had, all you'd have to do with that is change it to log form. Right? That's base e. Log base e. Exponent goes by itself. and 2 is the argument. And remember, log base e is, how do we abbreviate that? ln. So all you'd have to do on your calculator is hit the ln button, hit 2, and then you're done. But that's not our problem either. So this is not a problem that you can do algebraically. I'm not sure of any way to get x by itself there. So one thing we can do when you can't solve something algebraically is look at a different way to solve it. Right? So for this, I just want to show you that there are other ways to solve log equations besides just using the properties in algebra. So look what's on the left. It says x plus e to the x. Let me show you what that looks like if you draw it. So here's that. I want the divider. All right. X plus e to the x. And that looks kind of straight for a little while, but then I think it starts to curve. You'll notice that after the y-axis curves up. All right. So that part in blue is just that right there. Now, what I'm going to do is I'm going to graph the other side. Just a 2. Okay? 2, that's just simple, as very simple equation. It's just a horizontal line at the number 2. So let me put that in, and you can see what that looks like. Okay, so the equation on the left is in blue. The thing on the right is in red. Now, I'm trying to find out where the blue one equals the red one. What do you think that means visually in that picture? It's where they cross, where they intersect. Right? And if you have a calculator like that, you can automatically calculate, using the fifth option down, where two things intersect. And very easily, the calculator can tell me, just by hitting enter, that they intersect at 0.44. Right? How would you get that answer algebraically? I'm not sure. That's a tough problem to solve. But you can do it other ways, and that's what I just wanted you to see. That there are other ways to solve these kinds of problems if you know how to use graphing calculators. Okay? We don't really use graphing calculators too much in here. I might have shown you a couple things on them, but they are handy, especially for a problem like that.
So that's not good.
Not knowing how to do that. You may have a question like, if you couldn't solve something algebraically, what's another way you could do it? And explain to me how you could do it. You don't have to tell me the exact buttons to press, but just the concept of what I just showed. Okay. So any questions on that one? All right, so last one. It's actually, we skipped 7, so this is really example 9. I'll give you guys maybe like 5 minutes and try that. Okay, so this is like example 2. So if you get stuck, go back, look at example 2, and then we'll go through it together, and then I'll talk about the test for tonight. All right, so this one very similar to example 2. We've got two logs that are separate, same base. What's the first thing we should try to do with the two logs that are separate? Yep, we're going to combine them. Okay, when we combine them, is the base going to change? No. Base always stays the same. Now, there are two rules for combining. You either multiply or you divide. This one is addition. So with addition, combining them, what operation do you use? Multiplication. Right. So it's going to be x times x minus 3. Now, that x times x minus 3, I put it in brackets because that's all the argument, the whole thing. Now we should distribute that out. Alyssa, what do you get when you distribute that out?
X squared minus 3x.
Now I'm just going to use regular parentheses because I don't have two sets of grouping symbols anymore. I did the distributive property, so that got rid of one set of my grouping symbols. Okay. So now the next thing we have to do is the last thing that I've taught you that has to do with logs. After that step, it's all algebra. So what should I do with this equation now?
Exponential.
Yeah, we're going to change that to exponential form. Okay, so when I change it, Brianna, what's my base? 4. Yashira, what's my exponent? 1. And Sebastian, what's going to go on the other side?
X squared minus 3x.
Yep. Okay. Now, my suggestion when you're trying to solve a quadratic is always keep the x squared positive. It is, so we don't have to mess with that. But we want to make sure we get it equal to what? 0. Okay, we're going to get this equal to 0. How would you move 4 to the first over to the other side? Courtney? Subtract. That's gone. Okay, so we got 0. That's what you're looking for. X squared minus 3x minus 4. Okay. Once you get a quadratic equal to 0, what are your two options to try to solve it? Grace? Can you tell me what one option would be to try to solve that?
Factor.
Factor. Yep. And what if factor didn't work? What could you do if you had to? Yeah.
Quadratic.
Good. Could you quadratic formula? Where A is 1, B is -3, C is -4. You could even do quadratic formula right now if you don't like factoring. But if you can factor it, it'll be quicker, usually. Right? So Andrew, when I want to factor, what's the first thing I write down? Yes, good job. Parentheses. Start with that. How about Justin? What's going to be my first two terms? Yep, and x. X times x is x squared. Now, I've got a negative middle and a negative constant. So we're going to have to end up multiplying two things together to get a -4. So what do my signs have to be? Yeah?
Positive, negative.
Right. Positive, negative. Anytime this is a negative right there, you always have to have one of each. All right, so we got, got that. Now, two numbers that multiply to give me 4 and subtract to give me 3. Yep. 4 and 1. Now, you want to do 4 and 1 or 1 and 4? 1 and 4, let's check it. So the way I check it is I just FOIL it and see what happens. X times x is x squared, that's good. X times -4 is -4x. 1 times x plus 1x, -4 plus 1, perfect, -3. Okay. Now my last step is I just have to figure out what would make these two factors 0. Stephen, what would make this first factor 0?
Would you subtract 1?
Yep, and what would you get for x?
Just -1.
-1. And Jason, how about the other factor? 4. Okay, so am I good? Is there anything else I have to do?
Yeah.
What do I have to do? Yeah. Just plug them back in, make sure you never take the log of a negative. Let's check -1. Can you plug -1 in for x? Anything important? No. If you plug it in here, you're going to be log of -1. You can't do it. Now, 4 you could plug in, and we should be able to check it. If you plug it in, you'd have log base 4 of 4 plus log base 4 of 1. 4 minus 3 is 1. That's a special pattern. What's log base 4 of 4? What number does that come out to? 1. That's 1 plus anytime you take the log of 1, doesn't matter what the base is, the logarithm of 1 is always what? It's always 0. And 1 plus 0 gives me 1. Yeah, that one works. So, cross it out. So that's the second type of thing that can happen. One answer works, one answer doesn't. Okay, the third thing, which we didn't try one, is where you check them and you have to cross both of them out. In that case, if they both crossed out and it was a multiple choice question, you might see that symbol, which means that there is no solution. Okay. All right, questions on that? All right, so that would be the homework assignment if we were doing a regular homework from the book, but you guys are not. So for this class, your homework will be the take-home. The take-home is due by 8:30 a.m. tomorrow, December 20th. Make sure you give the test directly to me. Do not put it under my door. Don't leave it like with the main office or something, because if I don't have it by 8:30 and you say, oh, well, I put it under your door at like 6 a.m. or something, I don't know. It's gone. It ends up gone. You know, if somebody throws it away. So make sure you give it directly to me. If you are absent, okay, the test would still be due by the deadline if you choose to do it as a take-home. All right, it would be due tomorrow by 8:30. Okay. If the test is late, it won't be accepted. Okay. If it's after 8:30, it will be a 0. So if you decide to do it as a take-home, then pretty much you're agreeing to all that. Okay. If you don't want to do it as a take-home, then we can figure out a time for you to do it in class instead. Okay. So that might apply, like if you know you're going to be absent and you don't have internet, you can't take a picture of it, you have no way to get it to me, and you know you can't be here tomorrow. Probably not a good idea to do it as a take-home. All right. But if you are absent, you could just take a picture and send it to my email. It would have to be by 8:30. Okay. So if it comes in at like 9:05, no good. Make sure you send it from your Monty Tech email. Right. Very easy to prove as long as you send it from there. What time you sent it at. Right? And make sure you check your sent mail and it's in sent. Right? Sometimes people they write the email and they put it in as attachment, they don't click send, and then it's not in their sent mail, so they have no way to prove that they sent it at a certain time. Right? So check and make sure it's there. Right? Because even if we had like a problem with the email, you can show me that you tried to send it before 8:30. You're good. Okay. Any concerns or questions about that?
If you don't think you can make it due by 8:30, can you send it later?
Yeah.
Even if you're not absent, but you
Yep, you could send it to me by email, that's fine. So I will be here probably by 7:25, 7:30. So if you think you have to come before 8:30, I'll be here. I don't know if you're coming to this class tomorrow. I don't think so. You're probably going right to the assembly from period 1. That would be my guess. Is there anybody that doesn't want to do it as a take-home because something there concerns them and they can't do it? So everybody that's here is doing it as the take-home. Okay, easy enough.